Hello students, this is Poonam teacher back with a new video of Science 1, and today I'll be teaching you extraction of reactive metals. So the metals which are placed at the top of the reactivity series, as I've taught you in my previous video, these are highly reactive, as in the case of potassium, sodium, aluminium and so on. And their reactivity keeps on decreasing as we go down the series, but I'll show you over here. See, this is the reactivity series. And here potassium, sodium, lithium, calcium, these are all highly reactive metals. So the metals which are placed at the top of the reactivity series are highly reactive, and then the reactivity, it goes on decreasing as we move down. So potassium, sodium, aluminium, these metals are extracted by electrolytic reduction, because these are highly reactive. The metals, they can react with a dilute acid to give hydrogen gas, or such kind of reactive metals, they catches fire even at the room temperature, and because of this the extraction of such metals is done by electrolytic reduction. And the reason behind the reactivity is that they easily loses the electrons to form the cations from their outermost shell. Wait, I'll show you over here. See, this is potassium with atomic number 29 and electronic configuration 2881. So it has only one electron in its outermost shell, so it will lose this one electron easily and will form cation. Then sodium, atomic number 11, electronic configuration 281, and it also contains one electron in its outermost shell, and that is why it loses this one electron and forms cation easily. Even in the case of aluminium with atomic number 13 and electronic configuration 283, contains 3 electrons into its outermost shell, so loses 3 electrons easily and forms the cation. So this is the reason behind their reactivity, as they contains very less number of electrons into its outermost shell, they loses that electron easily and forms the cation, and this is the reason behind their reactivity. So all these metals are extracted by electrolytic reduction, and that we shall see now. Now see, these metals, the metals like sodium, calcium, magnesium, these are obtained by electrolysis of their molten chloride salts. Molten chloride salts means if you are taking sodium, it is going to be NaCl, calcium chloride, magnesium chloride, aluminium and aluminium chloride. Then what will happen, this salts, this will be taken into the electrolytic vessel like this. See, if you are taking aluminium chloride, that aluminium chloride solution, that will be taken into this electrolytic vessel like this. Then there are going to be 2 electrodes like cathode, which is going to be connected to the negative terminal of the battery, anode, that is going to be connected to the positive terminal of the battery. And when the electric current will pass through it, and if you are taking aluminium chloride, the dissociation will first take place into aluminium cation like this, aluminium ion, and then this chloride ion like this. Then that aluminium which has lose its electron and form the cation, that aluminium cation will try to gain its lost electrons, and then it will be reduced like this and will form aluminium. So reduction will take place at cathode. So this is how the electrolytic reduction of the metallic chlorides will take place, and the metal can be extracted from that electrode, from the cathode. If you are taking NaCl, dissociation will take place like this, and then at cathode the following reaction will take place. Sodium cation will gain its one electron, it will be reduced and will form sodium metal. Then potassium chloride will first dissociate to form potassium ion and chloride ion. Then that potassium ion will gain its lost electron and will form potassium metal. That means again the reduction will take place at cathode. So like this, the electrolytic reduction takes place and the metals are obtained on the cathode. So this is how the electrode reactions will take place, and see, it is given into your book also, that how the sodium cation or the sodium ion, it's gain its lost electron and it reduces to sodium metal, and the oxidation of the chlorine will take place at anode. So cathode is the reduction electrode while anode is the oxidation electrode.